All right, diving in today, folks. We're going deep on data deduplication. It's something we all deal with, right? Photos, documents, software. It seems like our digital world just keeps getting bigger, and we're drowning in data. We've got a bunch of articles here, some really informative stuff to help us figure out how to manage this massive amount of information.
Yeah, exactly. And when you get down to it, data deduplication is all about being smart, efficient with our storage. It's finding those duplicates, those unnecessary copies of data, and getting rid of them. Like, think about it. If you had 10 copies of the same family photo on your computer, it'd fill up so fast.
Oh, totally. My photo library is already a mess as it is.
Right. So deduplication is like having a system that recognizes those identical photos and says, okay, we only need one of these, and then it keeps track of all the other places you thought you needed that photo.
So it's like a master list, a reference point.
Yeah,
Instead of having a ton of copies, you have one original and then just a bunch of shortcuts pointing back to it.
that's a great way to put it. Yeah.
That's really smart. So listeners, why should you care about this? Well, whether you're just trying to organize your own digital life, thinking about cloud storage or backups, or you're in a job where data management is a big deal, knowing how deduplication works can be super helpful. We've gone through a ton of research, articles explaining the concept, different ways to use it, and even some of the technical nitty-gritty. We want to break it down for you, make it clear, interesting, and most importantly, useful.
Absolutely.
Okay, let's start with the basics. What is actually happening when data gets deduplicated?
Well, it starts with a scan of your storage system. This could be your personal laptop, a giant server farm, whatever you're using to store data. The system basically searches for identical pieces of information. And once it finds those matches, it doesn't just delete everything else. It's smarter than that. It keeps one unique copy of that data and replaces all the redundant copies with pointers or links that point back to the original.
Okay, so it's not just deleting, it's like creating a map. Okay, that makes sense. So how does it actually figure out what's a duplicate? It can't just be looking at file names, right? Because I could have, vacation photo 1 and vacation photo 2, but they're the same picture.
Yeah, you got it. File names can be totally misleading. So deduplication systems use a much more sophisticated method. They use unique identifiers, often called hashes. Think of a hash as a kind of like a digital fingerprint, super specific to that piece of data.
Okay, like a unique code.
Exactly. These systems compare the fingerprints, and if two pieces of data have the same hash, boom, they know it's a match.
So one fingerprint, one actual piece of data,
Yeah.
and the rest are just directions saying, go look over there.
That's it.
Okay. Now, I noticed in the research that there were different levels of how precise this deduplication can be. Can you explain that a bit?
Sure. So you have different levels of granularity. The simplest one is file level deduplication. The system just checks if two files are exactly the same byte for byte.
Okay, so the whole file has to be identical.
Exactly. Then there's block level, which breaks files into smaller chunks, like fixed size blocks, and compares those.
Okay.
And finally, you've got byte level, the most detailed. It compares data at the individual byte level.
Wow, that's getting really deep.
It is. And the more precise you get, the more duplicates you can find, which means bigger storage savings.
Makes sense. But I guess that also takes more processing power, right? The more detail it gets.
Exactly. It's a trade-off. More precision requires more horsepower.
That's interesting. So if I had a huge video file and I just made a small edit, a block level system would be better at spotting the duplicates than a file level, right?
Absolutely. File level would see them as completely different files, but block level would say, hey, most of these chunks are still the same. It's much more efficient.
Okay, that makes sense. Now, another term that kept popping up was data deduplication ratio. What's that all about?
It's a way to measure how effective the deduplication is. Basically, it compares the original data size to the size after deduplication. So let's say you have a 10.1 ratio. That means for every 10 gigabytes you started with, you're now only storing 1 gigabyte.
Wow, it's a big difference.
It is. And a higher ratio means you've gotten rid of more duplicates, so your storage is more efficient. But it's not a fixed number.
Oh, right, because it depends on what kind of data you have.
Exactly. Like if you have a lot of virtual machines with the same operating system, you'll see a really high ratio because there's a ton of repetition.
Makes sense. Now, our articles also talked about some key factors that affect how much you can actually deduplicate. Things like data retention, data type, change rate, and location. Can you break those down for us?
Sure. So data retention, basically how long you keep your data, is a big one.
Okay, makes sense.
The longer you keep it, the more chances for duplicates to build up, like through backups or different versions of files.
Right, because you're accumulating more data over time.
Exactly. Data type is important too. Some files, like software installers or operating system images, have a lot of identical content across different copies.
Oh, right, because they're basically the same thing every time.
Exactly. But other files, like documents that are constantly being updated, they might not have as many duplicates.
Okay, that makes sense.
Then there's the change rate, meaning how often a file is modified. Files that change a lot are less likely to have many duplicates. And finally, location matters. Sometimes you have the same file stored in multiple places, either on purpose as backups or by accident, just because you copied it a few times.
Oh, yeah, I'm totally guilty of that. Save as, save as, save as. We've all been there. It all adds up.
Right, so we've got a pretty good idea of what data deduplication is now. Let's get to the why. Why is it so important in our data-filled world?
Well, the most obvious reason is resource savings. You're using less storage space, which means spending less on hardware or cloud services.
That's always good.
But it's more than that. You're also saving on computing power because your systems have less data to churn through, less to back up. So everything runs more efficiently and costs less overall.
So it's not just about freeing up space on your hard drive, it's like a domino effect across your entire system. Exactly. And the problem with duplicate data isn't just about capacity. It can actually slow things down, make your computers work harder, and even cause confusion when people are working with what they think are unique files. Deduplication cleans all that up.
So it's like decluttering your digital life, making everything run smoother.
That's a great way to put it. And for a lot of companies, it's become a regular part of their IT routine. It's that important.
That makes sense. So where is deduplication most beneficial? What kind of scenarios really highlight its value?
Oh, there are a few key areas. One is with those general purpose file servers that companies use. Lots of people accessing, sharing, and changing files. You're bound to end up with a lot of duplicates. Multiple copies of documents, backups, different versions of software, all that stuff.
Yeah, I can even see that happening on a shared family computer, multiple people saving things.
Absolutely, it's everywhere.
No.
Now, another area is with virtual desktop infrastructure, VDI.
Okay, BD.
So in those setups, you have a bunch of virtual computers, and they often start with the same basic setup, the same operating system and applications.
Right, because they're like virtual clones.
Exactly. But that can take up a ton of storage space. And when everyone tries to start up their virtual desktops at the same time, it can cause a huge slowdown, what they call a VDI boot storm.
Oh, that doesn't sound good.
It's not. But deduplication comes to the rescue here. It eliminates the redundant data in those virtual desktops, and it can even make things run faster by caching frequently used data in memory.
So it's like preventing a traffic jam in your system.
Exactly. Now, what about backups? It seems like backups would create a lot of duplicates over time, right?
Yeah, because you're essentially copying everything again and again.
Right. And that's where deduplication is crucial for backups. The first backup you make is a full copy, but after that, it only stores the changes. Everything that hasn't changed is just a reference back to the original backup.
That's really smart.
It is. It saves tons of space and makes backups much faster. Plus, it means you can recover data more quickly if something goes wrong.
So it's a win-win-win. What about when you're moving large amounts of data, like transferring files between systems?
Oh, data transfers, that's another big one. Instead of sending entire files, especially if they're huge, deduplication only sends the parts that have actually changed.
Oh, that's a brilliant idea.
It saves a ton of bandwidth and makes transfers much faster, especially important if you have limited internet speed.
Yeah, that makes a lot of sense.
And finally, there are archival systems where you're storing data long-term. Deduplication is great for these because over time, as you add more data, you're bound to end up with duplicates. It helps keep those archives clean and efficient.
So it's like a spring cleaning for your old data.
Exactly. It helps keep everything tidy.
Okay, so we've covered the what, the why, and the when. Now let's get a little bit technical and talk about the how. What are the steps involved in this process?
All right, so one key step is called chunking. It's basically breaking down files into smaller, more manageable pieces called chunks.
Okay, so like slicing up a cake.
Exactly. And these chunks can be a fixed size or a variable size, depending on the system. The point is to break things down so the system can find duplicates, even within files that aren't entirely identical.
So if I change one paragraph in a document, it doesn't have to resave the whole thing.
Right. It just focuses on the parts that changed. Now, once the data is chunked up, the next step is hashing. Remember those digital fingerprints we talked about?
Yeah, the unique codes.
This is where they come in. A special function creates a unique hash for each chunk. And these hashes are much smaller than the actual data. So the system stores a database of all these hashes, and when it sees a new chunk, it checks the database. If there's a match, it knows it's a duplicate.
So it's like a giant library of fingerprints constantly being cross-referenced.
Exactly. And if a duplicate is found, the system doesn't store the whole chunk again. It creates an entry in a reference table.
Okay, what does that do?
It's basically a map that tells the system, hey, instead of storing this chunk here, go get it from over there where it's already stored.
So it's like a redirect.
Exactly. And this reference table is super important. It ensures that you can always reconstruct the original file, even though the duplicate data isn't actually stored multiple times.
So kind of like a behind-the-scenes librarian keeping everything organized.
That's a great way to think about it.
Mm.
Now, our sources also talked about different approaches to deduplication. One key distinction is between inline and post-process deduplication.
Okay, what's the difference there?
It's all about when the deduplication happens. Inline means it happens in real time as you're writing data to the storage.
So it's happening live in the moment.
Right. The system checks for duplicates before it even saves the data.
So you're saving space from the get-go.
Exactly. But it does require more processing power because it's happening constantly. Post-process deduplication, on the other hand, happens later after the data's already been stored.
Okay, so it's like a cleanup operation.
That's it. A separate process runs and analyzes all the data, finds the duplicates, and removes them. The advantage is that it doesn't slow down the initial data writing process, but you don't get the space savings right away.
So inline is more proactive, but post-process is less demanding on your system initially.
That's a good way to summarize it.
Okay, we also saw some different methods of deduplication. Block level, variable length, and file level. We touched on these before, but can you remind us of the differences?
Sure. So file level, the simplest one, just checks if entire files are identical. It's fast and easy, but not very precise. Block level, on the other hand, breaks files down into those fixed-size blocks and compares those.
Right, we talked about that.
It's more precise, but it can be more resource-intensive. And then you have variable length, which is kind of a hybrid approach. It uses algorithms to figure out the best way to break down the data, so it's more adaptable to different types of files.
Okay, so it's like a smart system that could adjust on the fly.
Exactly. Now, there's also source and target deduplication.
Okay, I'm not familiar with those terms.
These refer to where the deduplication happens, especially when you're talking about backups. Source means it happens on the computer where the data is coming from before it's sent to the backup.
So it's like deduplicating at the source before it even leaves the computer.
Right. This saves bandwidth because you're sending less data over the network, but it does use more resources on that source computer. Target deduplication, on the other hand, happens on the backup storage system itself after the data has been sent over.
So it's a trade-off where the processing happens.
Exactly. And finally, you have inline and post-process timing for deduplication. These basically describe the same concepts as the inline and post-process approaches we talked about earlier, just focusing on when the process happens.
Okay, so it's the same idea, just a different way of looking at it.
Exactly. It's all about when that deduplication magic occurs.
So we've talked a lot about the mechanics. Let's get back to the benefits. We know it saves storage space, but what are some of the other advantages?
Well, storage savings lead to economic benefits, right? Less to spend on hardware, energy costs, all that. But deduplication also improves disaster recovery because your backups are smaller, they're faster to create, and faster to restore from.
So it's like having a safety net that's easier to use.
Exactly. And another benefit is those smaller backup windows we talked about. Because there's less data to process, backups can happen more quickly and more frequently, which is great for businesses.
Right, because you want to minimize disruption to operations.
Exactly. And we also mentioned network efficiency. Less data being transferred means less strain on your network, which can be a big deal for some organizations. So all these things add up to significant economic benefits in the long run. You're saving money on storage, energy, bandwidth, and even staff time because there's less to manage.
So it's like a ripple effect of efficiency.
That's a great way to put it.
Now, we have to be fair and balanced here. What are some of the potential downsides or concerns with data deduplication?
Well, one thing to consider is the performance overhead. Deduplication can be a demanding process, especially those more granular methods like block level.
Right, because it's constantly analyzing data, creating hashes, and managing that reference table.
Exactly. So you need to make sure your systems can handle the load, and you might need to schedule deduplication during off-peak hours so it doesn't impact performance.
So you need to be strategic about when and how you do it.
Definitely. And another concern, although it's rare, is something called hash collisions. This is when two different pieces of data accidentally produce the same hash value.
Oh, that sounds bad.
It can be because the system might mistakenly identify unique data as a duplicate. But good deduplication systems use robust algorithms to minimize this risk, and they often have additional checks in place to catch any potential collisions.
Okay, so it's a risk, but it's mitigated by good technology.
Exactly. Now, another thing to consider is data integrity. If that metadata, those reference tables, gets corrupted somehow, it can be a problem. You might not be able to reconstruct your files properly.
So you need to make sure the metadata is protected.
Absolutely. Backups and redundancy are crucial for that metadata.
Okay, that makes sense. Are there any other downsides?
Well, remember that extra metadata we talked about, the fingerprint files and reference tables? They do take up some storage space. It's usually much less than the space you save from deduplication, but it's still something to keep in mind. And then there's the cost of implementation. The software and hardware can be expensive, and it takes time to set everything up and manage it.
So there are definitely some upfront costs and ongoing maintenance to think about.
You got it.
Okay, so let's wrap up with some real-world examples. Our sources had some interesting use cases for data deduplication.
Yeah, some really cool examples like in customer relationship management systems, CRMs.
Okay, CRMs.
Businesses often have duplicate customer records, which can cause all sorts of problems. Deduplication helps clean that up, giving them a single, accurate view of each customer.
That makes a lot of sense, especially for things like marketing and customer service.
Absolutely. And another area is data integration, like when two companies merge and they need to combine their databases.
Oh, yeah, that would be a mess without deduplication.
It would. Deduplication makes sure they're not storing duplicate records from the two separate systems. It keeps everything consistent and accurate. And then there's virtual computing, which we talked about before. Deduplication is super important for making those virtual environments run smoothly and efficiently.
Okay, and what about other industries?
Well, banking is a big one. They deal with massive amounts of data, and deduplication helps them reduce storage costs, improve security, and even detect fraud more effectively. It's really a versatile technology with applications across many different industries.
So if you're dealing with lots of data, deduplication is probably something to consider.
For sure.
All right, so if an organization is thinking about implementing deduplication, what are some key factors they should consider when choosing a solution?
The first thing is performance. Different methods have different demands on your system, so you need to choose a solution that matches your performance needs and your budget.
Okay, so make sure it can handle the workload. What else?
Scalability is important. You want a system that can grow with your data needs. You don't want to have to rip and replace everything every time your data volume increases.
Right, you need something that can adapt.
Exactly. Integration is also key. You want a solution that plays well with your existing storage, backups, and other systems.
So no data silos, everything working together smoothly.
That's the goal. And of course, cost is always a factor. You need to weigh the upfront investment against the long-term savings you'll get from deduplication.
Okay, so it's a balancing act of performance, scalability, integration, and cost. Now, before we wrap up, I want to mention our sponsor for this deep dive, Stonefly.
Oh yeah, Stonefly. They've been doing this for a long time, pioneers in storage, backup, and disaster recovery solutions.
And I understand they offer some pretty advanced data services.
They do. Things like immutable snapshots, which basically create a tamper-proof copy of your data for protection.
Okay, so that's like an extra layer of security.
Exactly. They also have AES-256 encryption, which is a very strong encryption standard for keeping your data safe, and synchronous and asynchronous replication for high availability and disaster recovery.
So they've got all the bases covered.
Pretty much. They also have intelligent data tiering, smart flash caching, and even ransomware protection. They're really trying to stay ahead of the curve when it comes to data security and management.
That's impressive. So for listeners who are struggling with data protection, need more storage, want to boost performance, or are thinking about upgrading their systems, Stonefly sounds like a great resource to check out.
Definitely. They have a lot to offer businesses of all sizes, and they're known for their competitive pricing and excellent support.
That's good to know. And speaking of offers, I believe Stonefly has a special promotion running right now.
They do. For a limited time, listeners can choose between $10 immutable and air-gapped backup services, or they can get a 70-terabyte backup and disaster recovery appliance for just $700.
Wow, 70 terabytes for $700. That's a pretty amazing deal.
It is. And this appliance can be expanded up to 4 petabytes. Plus, it includes advanced ransomware protection.
So it's a great opportunity for businesses to really enhance their data security and recovery capabilities.
Absolutely.
All right, so as we come to the end of our deep dive into data deduplication, it's clear that this is a really important technique for managing the ever-growing flood of data in our world.
Absolutely. It's about being efficient, saving resources, and ultimately making our digital lives a little bit easier.
So as you go about your day, think about all the data you encounter. Where might there be hidden duplicates lurking? And how could you benefit from deduplication, both personally and professionally? We've just scratched the surface here, but hopefully this has given you a good foundation for understanding this powerful technology.
And remember, there's always more to learn. Keep exploring, keep asking questions, and keep pushing the boundaries of what's possible with your data.
Well said. Thanks for joining us on this deep dive into data deduplication.
It's been a pleasure.
Until next time, keep diving deep.